Hey guys, it's Mr. Zamora. Just leaving you a quick video on nonlinear inequalities. These are a piece of cake. So hopefully you realize that doing inequalities with graphing is a lot easier than working with them algebraically. It just makes a lot of sense. So I'm going to show you that transfers for any type of function. So I have here some examples and some for you to practice on your own as well. A total of 6 examples. 3 of them I do with you and 3 of them you do on your own. Okay. So the first example that I have is a square root inequality. So I have right here written the square root of x plus 3 minus 2 is less than 0. So just like with quadratics, the first thing I'm going to do is I'm going to graph that function. All right. I'm not going to type in the whole inequality. Regular Desmos might be able to produce an image, but testing Desmos would never be able to do that. So that way we can analyze the function. This is a function that you learned not so long ago, right? It's a function that moves 3 units to the left, 2 units down. And here it is. The question is, when is the function less than 0? In other words, when are the outputs less than 0? Or when are the outputs below the x-axis? That's really all you have to ask yourself, right? As usual, your first step is to locate that 0. So here my 0 is at 1, all right? Therefore, this function is going to be less than 0, or the outputs are going to be less than 0 anywhere before 1, all right? However, this function does stop at -3. So I have right here, the graph is less than 0 for all inputs that are less than 1. All right. But greater than -3. All right. So you have to sandwich your answer between -3 and 1. So we say -3 is less than x is less than 1. So that's how you write whenever the answer is in between a set of numbers. Okay. And then I leave you an example right there for you to try on your own. All right. We can do the same with an exponential function. All right. Let's see. So with an exponential inequality, let's say we have 2 times 3 to the x minus 3 is less than 0. So once again, we're going to look at the graph that it produces, and we're just going to look at the part that is below the x-axis. That is the part that is less than 0. If the question were greater than 0, then we'd list the domain that is above the x-axis. All right. So once again, I locate my 0. It's at 0.369. And I say, well, the function is less than 0 for x's that are less than 0.369. All right. So that is my solution. And I leave you an example for you to try on your own. All right. And last, we can do this also with a rational equation. So here I ask a simple question: when is 1 over x greater than 0? So here's the graph of 1 over x, all right, a rational or inverse equation function. And this function is greater than 0. Really, the entire right side is greater than 0, all right? So this means that any x greater than 0 is my solution set. If the question were when is it less than 0, then we say x is less than 0, okay? So that is basically how you do these problems. You really just, 1, look at the function, and 2, look at which part of the function is above the x-axis if it's greater than, or below the x-axis if it's less than. And that's all I got for you. Check out my new office. I've ran away from my kids because they have been interrupting my videos. So here we are in the sunroom. Anyway, hope this helps. And if you have any questions, let me know. But go ahead and try 3 examples of your own, and we'll see how this goes. Okay? Very good. Take care, guys.